All right, it's 10:31, so I'll get started. Hello, good morning, everyone. I am working out of the West Coast, but if you're in a different time zone, I hope you're still having a great day and that you're enjoying all the programming at Day of Security. Today, I will be talking about how to build a simple cloud alerting pipeline with examples of alerts going from GCP to Slack and from AWS to PagerDuty. A little bit about myself. I am a senior security engineer at Cruise, and my recent focus has been around cloud security, platform security, secrets management, and automation tooling. And part of why I want to share this talk with you all today is because a lot of my work in auditing and remediating issues within the cloud infrastructure became much more manageable when I started leveraging and stringing together these cloud services to build out alerting pipelines. And the examples and best practices I'm about to share with you are just personal recommendations. And I hope that it is at least a helpful starting point for those of you looking to build out a lightweight alerting tool. Cool. So I'll start by covering why we're even talking about the cloud. And then I'll move on to why we should leverage cloud services for security alerting. And then I'll give two examples of cloud alerting pipelines that you can use to build services to build out alerting pipelines in two of the major cloud providers, GCP and AWS. All right, so why the cloud? Over the last few years, there's been so much hype around this concept of the cloud, to the point that even the art and comics industry is getting a pretty good kick out of it. But what exactly makes it such a popular infrastructure solution? And I gotta give you all a few seconds to digest and appreciate these works of art. Awesome. So without spending the entire talk simply enumerating the pros and cons of cloud infrastructure versus on-prem versus public, private, hybrid cloud, I wanted to just highlight a few things that make it stand out to me. First, it provides cost savings. When you think about it in terms of capital expenditures, you save by not having to build out or manage your own data centers and underlying infrastructure. And many cloud services use a pay-as-you-go or pay-per-use model, so you're less likely to waste money on resources your company doesn't need. I'm not saying that never happens, especially with legacy systems and accumulated tech debt, but it's a little more cost-effective. Not to mention, your accounting team probably prefers having a centralized billing dashboard that tells them exactly what services or accounts are costing the most. The cloud also offers flexibility and scalability. You don't have to worry about running out of rack space because the cloud providers take care of it for you. Ephemeral virtual machines and auto-scaling groups allow you to spin up workloads easily according to demand, which makes horizontal scaling more serviceable. Moreover, since the cloud providers operate in global and regional locations, you can optimize for performance and lower latency by configuring resources and servers that are regionally closer to consumers without actually having to build your own physical data centers. For example, if you have a web app that's serving folks in Asia, you may want to deploy the server in the Tokyo region as opposed to deploying it in the US East Ohio region. And luckily, setting that up in the cloud is just a matter of a few clicks in the console. And finally, cloud providers offer a wide ecosystem of services and tools. I think this is a point that's often missed in, say, like the pros and cons or benefits of the cloud's list. And this is something that I'll want to touch on a little more, which is why I have the asterisk next to the point. As you can see in the slide, GCP and AWS both have their own set of cloud-based services. Common ones you may have heard of in GCP include BigQuery, Cloud Storage, Compute Engine, and in AWS, EC2, RDS, S3. All right, so why are we talking about security alerts in the cloud then? The bottom line here is that better visibility helps us better quantify and address risk in our cloud environments. And when we do want to alert on signals from our cloud environment, we can make use of that ecosystem of services and tools we just talked about, in tandem with cloud-native data and logs to string together a pipeline that will output an alert to a chosen destination. And this slide shows two examples of that, which I'll go into more details in a bit. So again, with this cloud-based approach, We can have more visibility into our infrastructure and also easily build out monitoring and alerting capabilities. Eventually, once we've captured these signals, we can even develop remediation capabilities based on this underlying architecture. Okay, so now I'll jump into the first sample alerting pipeline architecture, which is based in Google Cloud Platform. Okay, since not everyone may be familiar with GCP, I wanted to briefly go over each service component that we'll be using in the sample pipeline. First, we have cloud logging. It was rebranded from Stackdriver into cloud logging in 2020, so you might hear both used interchangeably. It allows you to store, search, analyze, monitor, and alert on logging data and events from GCP and AWS. PubSub. It's pretty much what it sounds like. It's an asynchronous messaging service that decouples publishers, which are services that produce events, from subscribers, which are services that process events. Google Cloud Functions is a serverless execution environment for building and connecting cloud services. A function is triggered when an event being watched is fired. It can be triggered by things such as PubSub, topics. There are others amongst it that I can't think of off the top of my head, but it is an event-based function. Google Kubernetes Engine, GKE provides a managed environment for deploying, managing, and scaling containerized applications using nodes grouped together to form a cluster. Okay, so now that we've gone over the components a little bit, let's put them together. All right, I hope everyone can see the diagram. Maybe full screen it if it's a little small. But I'll go over it from left to right. So in simple terms, this pipeline will trigger a Slack message to a user when they access a GCP resource that we are monitoring. That's what the whole intent of this flow is. So if we go from left to right, we'll see that the user accesses a resource in project one. Let's say they try to access a BigQuery dataset or a GCP instance, or they try to read some data from a Cloud SQL instance. Then cloud logging will automatically log this violation, or really event, because we don't have full info about it yet. So maybe it's just an event as opposed to a violation. Then cloud logging forwards this event to our logging sync, which is the PubSub topic in the security project. And note that cloud logging chooses which events get forwarded to the sync based on a log filter that we get to define. Upon receipt, the PubSub topic will trigger the cloud function, which will run and send a post request to a Slack endpoint. And if you're able to see the slide's fine print, you'll see in the tiny Slack message that says, "Hello, user. You have tried to access this GCP resource from this country and this IP. Is this you?" And voila, we have managed to generate a real-time alert just by feeding the output of one service as the input to a subsequent service. And as a bonus, without ever having to deliberately deploy a single server. It's completely serverless. All right, and just to give you another variation of this pipeline, I've replaced the cloud function component with GKE to demonstrate a not so serverless approach. I'll flip back and forth just so you see where the difference is. Awesome. The end result of sending a Slack alert to the user is still the same. The only difference is the component sending the message. In this scenario, we deploy an application container into GKE that will subscribe to incoming events from the PubSub topic. And while it seems like this might add unnecessary complexity, there are valid use cases and potential benefits to using this architecture as such as if you want to inject more complex application logic, enrich the event data using other contexts, or enable caching and deduplication capabilities. In fact, if you think about our particular use case, that could be really useful, considering a case where a user may access a resource over and over again. And we don't want to accidentally spam them with 1,000 alerts just for that action. Instead, we want to maybe alert them once in the last 60 minutes or so. It could also potentially be more cost-effective if you take the server-based approach, server-based, serverless, non-serverless, serverful if you may, if you have a high volume log, if you have logs that come in at a high volume. that would trigger hundreds and thousands of these Google Cloud functions, at which point the latency and cost could really skyrocket. So already we're seeing that the basic architecture can support various scenarios, and we can adjust complexity and customization based on our needs. Okay, so now let's jump into a similar example for AWS. For AWS service components, we'll touch on CloudTrail, CloudWatch, and Lambdas. CloudTrail. It provides event history for your AWS account activity, including actions taken through the console, SDKs, CLI, and other AWS services. With CloudWatch, it is a monitoring and management service that provides data and actionable insights for AWS, hybrid and on-premise applications and infrastructure resources. Lambda. It's a compute service that lets you run code without provisioning or managing servers. Lambda runs your code only when needed and scales automatically from a few requests per day to thousands per second. So if you think about this and put it next to GCP and other cloud providers, there are a lot of overlapping tools and services that have similar functionality. While they're not configured exactly the same way and they have their own specific features, you can think of them analogously. So for example, for me, I think of Lambdas and Cloud Functions as like side-by-side comparisons, plus minus a couple of features here and there, and other configuration tweaks. Okay, so let's see the AWS pipeline. This example pipeline is very similar to the one that we just saw in GCP in terms of the event-driven and cloud services-based approach. The scenario here is that if a user creates a long-lived EC2 key pair, we will page someone on the security team to triage the event. This is just a plain example. And from left to right, we'll see that a user creates an EC2 key pair in account 1. Let's just say that this is an event that we have decided we want to monitor as high risk or high priority. Secondly, CloudTrail logs this create EC2 key pair API event. And then based on a CloudWatch rule we've configured within account 1, CloudWatch will use an event bus to forward the create EC2 key pair API events to the security account, which in turn has its own CloudWatch rule that will trigger a Lambda function that also is in the security account. The Lambda function contains basic code that sends a post request to a PagerDuty endpoint. And tools like PagerDuty and Slack, they have very well-documented REST APIs that make it really easy for you to just write a simple piece of code to send a post request to them and send information over. And there we have it. So for both the GCP and AWS pipelines that I've shared, they can also serve as a basis for auto remediation work. For example, in this case, if we wanted to page someone and also delete the EC2 key pair, we could create another Lambda function to hook back into the original account to delete the key pair, given that you've set up the correct IAM trust policies and permissions and all. Another potential variation we can talk about here is that if you have data from another source, let's say coming from Sumo Logic or Datadog, that's not perhaps cloud native, you can also leverage this cloud alerting pipeline by configuring, let's say, an API gateway. If you configure an API gateway endpoint, you can have the data source send a webhook to hit that endpoint, which will then trigger a Lambda function, rather than using a CloudWatch event. My point here is that this architecture is relatively flexible and can be repurposed accordingly. Some of the key points that you want to consider when you're creating an alerting pipeline like this is, do you have sort of a centralized logging area? So in GCP, we saw something with cloud logging. In AWS, we saw something like CloudTrail. And then the second thing that you might want to consider is there something that will process or pass on this information? For GCP, we saw PubSub. And then for AWS here, we're seeing CloudWatch as that mechanism. And then the last thing that in this simple architecture that's really helpful to have is something that can actually process and act on the data that you get. So in GCP, we saw Cloud Functions, and here in AWS, we're using Lambdas. Okay, So now that we've gone through some lightweight cloud alerting pipeline examples, I want to highlight some best practices while building out and operationalizing them. Make sure that the infrastructure components are codified. Use something like Terraform or CloudFormation so that if any component is accidentally deleted or lost, you can easily reapply a config file to spin everything back up. Another idea is that if you plan to reproduce this pipeline multiple times, or just want to avoid copy pasting everything multiple times in Terraform, you can even write up a Terraform module and just change out the variables accordingly. Then you wouldn't have to keep copy pasting and keep reusing Terraform code. The second important thing, this is often overlooked. Let me get into it. You want to document the purpose of the alerts, especially if they are user-facing. This is so that users know why they're being alerted and who to reach out to for guidance. It's seen as busy work in terms of like documentation and everything, but more often than not, it can save you a ton of time in explaining to each user why they're being alerted. If you alert someone, let's say in the Slack example, they'll probably drop into some security channel and be like, hey, I got this alert, tell me what's happening, why am I getting alerted? I didn't even know about this. So in those cases, it's really helpful to have documentation where you can just be like, hey, like, here's why we're doing this, and we look forward to cooperating with you somehow. And similarly, it's important to document runbooks for operators so that others on the team can further develop, help maintain, or reproduce this workflow. This also helps to alleviate bus factor concerns. So today we went over some relatively lightweight examples with a lot of flexibility for you to make it the way you want it to. And if you're interested in some more comprehensive cloud-based alerting frameworks, I'd encourage you to check out Airbnb Stream Alert, which is serverless, and Twilio's Sockless, which is also serverless. And there are a lot more on the interwebs if you look for it, but those are the ones I have top of mind. All right, so it's pretty short. Thanks, folks, for listening to my talk. And if you have any questions afterwards or want to chat, you can reach out to me on LinkedIn. Or if you want to help me revive my Twitter presence, you can hit me up at ShellTripleU. So feel free to let me know if you have any questions right now, since we have a few minutes, it seems. Or also feel free to let me know afterwards, and I'm happy to circle back. Ah, okay, we have a question. What is your preferred cloud platform and why? That is a hard one. I will say that part of it will be very biased because I will probably like the ones that I've worked with more recently. So that would put GCP and AWS into the mix there. I think both have their pros and cons in certain respects. So I'm thinking about, I actually really appreciate GCP's whole IAM hierarchy. They've kind of split it such that you can have the organization level, then you can have folders, then you can have projects that all kind of lead up to the same tree. Whereas I think in AWS, it's a little different where you have like separate accounts and they don't necessarily have to have any like hierarchical relationship to each other. Aside from like if you have an AWS organization and accounts that are listed as under the organization. But I like how GCP kind of does that natively. So there is that implicit hierarchical, what's the word I'm looking for? Inheritance there. So I do like that about GCP. There are things in AWS that I also like though, which are like the fact that every resource has an ARN that's like pretty standard for each resource. So it's really easy to identify resources, whereas sometimes in GCP, it's not as easy to identify resources. They have self-links. There are other attributes that you might have to search for, especially when you're doing auditing and remediation work. Okay. Yay, thanks, Caitlin. Yeah, their documentation is actually pretty great, especially, well, for some services and resources, documentation documentation is better than for others often is correlated to the amount of money each product makes. But I would suggest looking into the documentation, and I think the IAM hierarchy documentation is really well put together, and they give a ton of examples for you to look into that. And then when I was putting together this pipeline, I went through a lot of documentation on GCP to kind of figure out, hey, like how do you send cloud logging things to a sink, and what types of sinks are there? So in the example that I gave, the pub sub topic was a sink, but you can also set a BigQuery dataset as a sink. So if you want to be able to ship all those logs to a BigQuery table and then be able to query on that, that's also another option instead of having it go to a pub sub and then alerting. All right, so just 5 minutes left. I don't see a ton of questions coming through, but if you have any questions, again, you can find me on Twitter. You can reach out to me on LinkedIn. You can find me in the Slack workspace for a day of security. I'll be there most of the day, checking in and out, watching other speakers talk. And I'm really excited for the rest of the programming that we have and to see all these other amazing people speak about their work. And I will sign off now. Thank you all.